The story of the International Space Station, or ISS, begins with a fierce contest during the Cold War. Two superpowers, the United States and the Soviet Union, raced for the stars. This was the space race. It was about rockets reaching the moon and establishing a human presence in Earth orbit. The dream was to build outposts in the sky. These early visions were stepping stones born from competition, not collaboration. The Soviet Union took an early lead with the Salyut program in the 1970s. Salyut 1 became the world's first space station. These were relatively small structures with varied missions, from military observation to scientific experiments. Cosmonauts lived and worked aboard these stations for weeks, then months. The Salyuts taught us much about living in space despite technical difficulties. The United States responded with Skylab in 1973, made from converted parts of the Apollo program's Saturn V rocket. Skylab was much larger than the early Salyuts and hosted 3 crews of astronauts conducting a wide range of scientific research. Skylab's mission ended in 1979. Before the ISS, there was Mir, launched in 1986. Mir was the first modular space station, assembled in orbit from different parts. Mir hosted cosmonauts and international astronauts for long periods, setting records for human endurance in space. Mir became a symbol of Russian space prowess and a place where international cooperation began to bloom. This set the stage for the ISS. The end of the Cold War changed space exploration. Old rivalries faded and new realities emerged. Cooperation became the new way forward. The Shuttle Mir program was a key step. US astronauts and Russian cosmonauts worked together. This was a rehearsal for the International Space Station. The vision for a global space station grew. The ISS agreement was signed. The ISS became a symbol of global cooperation. A new era in space exploration had begun. The International Space Station's construction began in November 1998. The first piece was the Russian module Zarya, providing early power and propulsion. In December 1998, the US launched the Unity module, connecting it to Zarya. This marked the first connection between American and Russian hardware. The ISS symbolizes global cooperation and technological marvel. The International Space Station is often described as being like giant Lego in space due to its modular design. The station was built from many smaller, independent parts called modules. These modules were constructed on Earth by different countries and launched separately into orbit. Once in space, astronauts and robotic arms carefully connected them together. This approach was revolutionary for building such a large structure far from Earth. The advantages of this modular design are huge. Launching smaller pieces is much easier and safer. No rocket could lift the entire completed ISS into orbit at once. By breaking it down, each launch was more manageable. This phased construction allowed scientists to start using parts of the station even while other parts were still being built. Modular design also offers incredible flexibility. The ISS is not a static structure, it can evolve. New modules with new technologies or research facilities can be added over time. This ability to upgrade and expand is crucial for a long-duration facility like the ISS. It ensures the station can adapt to new scientific priorities and technological advancements. The ISS is a living, growing laboratory in the sky. The International Space Station is a world-class laboratory orbiting our planet at about 17,500 miles per hour. This unique vantage point and environment make it an unparalleled platform for scientific research. Scientists from all over the world can propose and conduct experiments on the ISS. These experiments cover a vast range of disciplines, helping us understand our universe, our planet, and ourselves. The ISS supports research in many key scientific areas. One major focus is human physiology, studying how the human body adapts to long periods in space. This is vital for planning future missions to the Moon or Mars. Material science is another important field as materials behave differently in microgravity. Earth observation from the ISS provides valuable data on climate change, weather patterns, and natural disasters. Astrophysics experiments study distant stars and galaxies. Many fascinating experiments have been conducted aboard the ISS. Scientists have studied how flames burn without the influence of gravity, which changes their shape and behavior. They have grown plants to see how they respond to microgravity, a key step for future space agriculture. New medicines have been tested, and the behavior of fluids in space has been investigated. The station itself is an experiment, testing life support systems and technologies for long-duration spaceflight. The discoveries made on the ISS have tangible benefits, such as better treatments for osteoporosis and improved industrial processes. Each experiment adds to our understanding and often sparks new questions, driving science ever forward. The ISS is in a continuous state of freefall, creating a microgravity environment. This state is called microgravity, meaning tiny gravity. For the astronauts and experiments on board, it feels like weightlessness. This is a truly magical environment for science. On Earth, gravity dominates many physical and biological processes. In microgravity, these effects are almost entirely removed. This allows scientists to observe phenomena that are normally hidden or masked by gravity's strong pull. Consider fluid physics. On Earth, if you spill water, it spreads out into a puddle due to gravity. In microgravity, a droplet of water will form a perfect sphere. Studying fluids in microgravity helps scientists understand fundamental properties like viscosity and diffusion. This knowledge is valuable for designing better fuel tanks, chemical reactors, and even medical devices on Earth. Materials science also benefits immensely. Without gravity causing sedimentation or convection, it is possible to grow larger, more perfect crystals. These high-quality crystals are invaluable for research in electronics and drug development. Understanding how materials solidify in microgravity can lead to improved manufacturing processes. The ISS provides a unique environment for groundbreaking scientific research. Astronauts live and work on the ISS for extended periods, typically around 6 months at a time. Some have stayed for nearly a year or even longer. These long-duration missions present unique challenges to the human body and mind. Understanding these challenges and finding ways to overcome them is a critical part of ISS research. The health effects of long stays in space are numerous. Without gravity, bones can lose density, and muscles can weaken and shrink. Astronauts' vision can be affected and the immune system can be altered. These are serious concerns for astronaut health. To combat these negative effects, astronauts follow a rigorous exercise regime for about 2 hours every day. They use specially designed equipment to simulate weight-bearing exercise. Their diet is carefully managed to ensure they get the right nutrients. Medical teams on Earth constantly monitor their health. This research is essential for enabling future, much longer journeys, such as missions to Mars. Beyond the physical challenges, there are psychological aspects to consider. Living in a confined space, far from home, with a small group of people for many months can be stressful. The ISS crews are carefully selected and trained for teamwork and resilience. Studying the psychological well-being of astronauts helps mission planners design better habitats and support systems for future deep space explorers. The International Space Station was an ambitious project with a planned operational lifetime. Initially, many thought it might operate for around 15 years. However, the station has proven to be remarkably robust and scientifically productive. Its mission has been extended multiple times by the international partners. This is a testament to its engineering success and its ongoing value to science and exploration. The story of the ISS is not over. It is entering a new and exciting chapter. Current plans indicate that the ISS is likely to continue operations until at least 2030. This continued commitment ensures that the unique research platform remains available to scientists worldwide. Maintaining an aging, complex facility like the ISS requires ongoing investment and effort. Engineers constantly monitor its systems, perform maintenance, and plan for upgrades. A significant development in recent years is the rise of commercial spaceflight. Private companies like SpaceX and Boeing now provide crew transportation services to the ISS. These commercial partnerships are becoming increasingly important for the station's logistics and its future evolution. Looking ahead, the ISS may become a hub for even more commercial activities. Companies like Axiom Space are planning to attach their own privately owned modules to the station. This transition would allow NASA and other space agencies to focus their resources on deep space exploration. The International Space Station stands as one of humanity's greatest achievements. For over 2 decades, it has symbolized international cooperation and peaceful goals. Orbiting above us, it reminds us of our ingenuity and collaboration. Its legacy extends beyond scientific data. It has changed space exploration and our place in the cosmos. The ISS has taught us invaluable lessons for future missions. We have learned to construct and maintain complex structures in space. We have mastered managing long-term international partnerships. We have gained knowledge about living and working in space. These lessons are crucial for future Moon and Mars missions. The ISS experience paves the way for the next era of exploration. NASA's Artemis program benefits from ISS know-how. The Lunar Gateway will draw on ISS principles. The ISS inspires millions, especially young people. It encourages careers in science, technology, engineering, and mathematics. The ISS shows that challenging frontiers can be reached. When we combine our talents and dreams, anything is possible.